All right, welcome everybody at the Area Robotics Community Group meeting of November 20th, 2024. So today is a community meeting where we have a couple of updates from the community, some announcements, and a presentation. Now this time it's going to be from Davide from Duckietown to present about the Duckiedrone. But I'll come to the setup of the meeting in 1 minute. There you go. So pretty much what I just said. So first, some announcements. Like we haven't had a meeting for a while, and that's also because of a reason. We had ROSCON in Odense, Denmark, and that was a lot of fun. We had an Area Robotics ROSCON meetup, and we had about between 80 and 100 people who showed up, which was really cool. And like anybody that was there, so like thanks for joining. And Drone Code Foundation provided drinks and pizza, so very much thanks to them for that. It was yeah, I didn't expect such a big turnout for it, for sure. The recordings of the ROSCON talks are out, so you can check them on the website of the ROSCON website. I must say that this year we I couldn't find an Area Robotics talk. I don't know if anybody put in a lightning talk about Area Robotics, and if you do, let know the title in the chat so I can actually forward it. But let's try again next year. Let's have more Area Robotics talks at ROSCON. The Autopilot conference was like about a week later. Ryan, you also gave a talk about Autopilot and ROS, or ROS 2 in particular, and the video link is right here, so you can share that in the chat if you'd like.
Yeah.
And if you
want the slides, let me know. For anyone. Public. Yeah. That was cool. That was cool. Lots of people doing cool stuff with drones. Not a ton of ROS stuff at the Autopilot conference, but you know, good to spread the word. I sort of wish I could have gone to ROSCON, but my employer didn't want me to go. We had too much stuff going on.
Well, there's always next year.
Singapore.
Singapore.
Oh, really? Singapore.
Next year.
Wow.
Yeah.
That's cool.
So if there's any time you should go, it should probably be next year. And that's have more. Then you can also present for Autopilot and ROS there.
Yep.
All right. Yeah, so there are a couple of other local ROSCONs coming up in December. So if you want to do a world tour, there's going to be in Germany, in India, and China. So you can check out the ROS discourse for that. But in case you've missed it. First of all, like the Area Robotic landscape is something that we kind of manage within the Area Robotic interest group. Where anybody can add information about Area Robotics. It's kind of an info hub of useful links to courses, hardware, etc. And you can find the link of it to it right here. And I will give you at least the updates that we had since our last meeting, which was October 11th. We had a couple of extra updates, namely during ROSCON, I found out that the University of Southern Denmark has a very cool drone center. A huge outdoor drone space that allows beyond line of sight flight. It was pretty cool. But they also have a yearly summer school there, so I've definitely added that to the Area Robotic landscape. They also have a master specialization of the robot system master in drones and autonomous systems. So that's pretty cool. That's on there. We also had somebody who gave a quadcopter build and programming manual for Carbon Aeronautics, which is kind of goes with the YouTube channel as well. And also we just have a couple of improvements to the landscape as well. We have a update for for the date of the page whenever it's updated. And now currently we're working on having a link checker, because currently there's a lot of dead links, and there's a lot of links now on the Area Robotic landscape. That's a bit difficult to really go through. So you can definitely check that out here. And I would say thanks to Alexis and Abdullah for your PR and your help, either adding the info or helping out with maintaining it. So yeah, let's see if we have anything Yeah, is there anybody that would like to share anything from the aerial robotics community? Anything that I missed with the announcements, or any cool courses that you know of, or anything important events that are coming up? This is the time. We have a couple of minutes reserved for that before we go into any presentations. So hands up to anybody who would like to share anything else. Maybe perhaps a project that you're working on.
Yeah, I'm working on lots of projects. I guess something interesting for the MavLink people out there is MavCesium. Let me get a link to that. So this is a 3D viewer for aerial vehicles. And so it's based on Cesium, which is a pretty popular web-based framework for visualizing things, and it works really well with drones. And so I've been working on, this is a very old repository originally, and I recently got that updated to actually work again. It was using a lot of web-based tools that were, APIs had disappeared. So it was like 8 years old without being touched, which is a long time for web stuff. But anyways, that's now working again, and it works with MavProxy as the ground station. I haven't yet tried it on PX4, but in theory, it's MavLink based, so should work. But anyways, the goal of this is to sort of, for the outdoor aerial, we don't really have a good way to have 3D visualization. QGC, I think, recently added support for this, but we really want to be able to see the vehicle, the terrain, the geofences, and the path plan in 3D for outdoor. And so I think that this is a pretty good foundational tool to build upon. Anyways, that's sort of what I've been working on the past couple of weeks is learning JavaScript for one, because I'm a backend developer. I have no idea how to use front end, and I'm really terrible at it. So it's sort of been a personal learning for me. But anyways, if you're struggling to visualize your robot in 3D and you want to learn JavaScript and you're bad at it like me, I think this is a good project to get involved, because there's a lot of little things to learn, and learning how to write little boxes with little buttons, and write a JavaScript function and learn about variables. So there's lots of little improvements if you want to get involved, and especially if you know a little bit of front end, it'd be nice to have some people. These are pretty small things. So I think this is a nice little fun tool to work on.
All right, thanks a lot.
Yeah.
Let's see if people can try it out. We have the link in the chat right here. Yeah, I saw that there was one hand that was up. Is that one still up? Anybody else that wants to share anything else?
I can go.
Sure, of course.
So hi, I'm Tejal. So I met him at ROSCON this year, and I'm new to the aerial robotics working group today. So this is the first time I'm joining. So I just wanted to share that I recently started working on a side project to actually integrate the bonsai mapping from Davide to actually do 3D planning with the quad rotor. So my plan is to integrate a 3D planner like OMPL and something to actually do 3D planning and avoid obstacles and stuff. So yeah, I just wanted to share a brief update about it. I just integrated it with AudioPilot, and now I'll be starting to work on collision checking and 3D planning.
All right, thanks a lot. I'm adding that link. We need to add all of these to the robotic landscape or share these. Very cool, thanks.
Yeah, that tool, I spent some time looking at it. It's really cool because this Bonks AI mapping engine was presented at last year's ROSCON as basically a successor to Octomap. So if you're a person that's doing indoor robotics, especially for aerial, this is definitely something to go check out.
Anybody else who wants to share their project that they've been working on, or any other projects that we should know about? I see that, Alexis, you've just joined. I also gave an update already about the aerial robotics landscape, about all of the cool, interesting things that you've been working on. Let's see, was there anything else? Cool. I think it's probably best for us then to go to the next part of the meeting. Oh, it's not a meeting by Armbo. One moment. Whoops. That was the previous presentation. I absolutely do not copy paste my all the meetings for slides. Davide is going to give the next presentation, and he's going to talk about introducing the DD24, Duckietown's latest platform on learning aerial robotics. And he's from Duckietown. We had Jacopo Ottani already presenting last year in September about the previous version of the Duckiedrone, and now there's going to be an update. So yeah, very curious about this. I'm going to stop sharing my slides.
All right.
And then you can go ahead and share your slides.
Okay, should be able to see my slides.
Yeah, perfect.
Yeah, okay. All right, so yeah, hi everyone. I'm Davide. I'm a robotics autonomy engineer at Duckietown. And I have in this call also Jacopo, who's the co-founder and CEO of the company. And we're gonna talk about the new Duckiedrone, the DD24. So I'm going to give you a little introduction to Duckietown, Duckietown Sky, and I'm going to show you the new drone that we have developed right here as well, the DD24. And then I'm going to leave some space for questions and answers. So Duckietown is a American-Swiss edtech startup that started at MIT as a class in 2016. And the aim of Duckietown is to democratize access to the science and technology of robot autonomy. So we achieved that through spreading throughout the world. We have 200 partner universities, about 150 companies, and more than 10,000 alumni. And we have delivered robots in 68 countries and counting. So Duckietown is a complete platform. There's autonomous vehicles and drones. There's a smart city, simulation environments, pedagogical materials. And the aim is to allow teaching, learning, and doing mobile robotics research with a focus on higher education. So it includes the hardware, self-driving cars, drones, and smart city, the software with development environments, simulators, and autonomy code, pedagogical material, so curricula, class materials, and we also have a very big community on Slack and Stack Overflow spread across the globe. We aim to teach real-world skills and tools of the job, such as Python, ROS, Docker, and Git. So the experience has a focus on the learning experience of the student, which has to be joyful, hands-on, and effective. We aim to make this accessible in a way that is affordable to most people, inclusive, and available worldwide. So the aim is to have a simple experience, but not easy. As I'm sure everyone here has experience in working in robotics, there's no shying away from the complexity of robot autonomy. So that's something we want the students to understand and to learn from and learn how to handle as well. So we have Duckietown ROS and Duckietown Sky, which are the two platforms that we offer. And the design philosophy is to have a minimal autonomy platform for single and multi-robot autonomous behaviors. It has to be scalable in complexity. So there are fixed rules, but no fixed maps. You can build a map any size you want. And it's expandable at will. The focus of this talk is going to be on the Duckietown Sky. So the Duckietown Sky experience that we offer is targeted towards undergrads and advanced senior high schoolers, as it requires as prerequisites basic math, physics, and some Python coding skills. So we have learning experiences that walk the student through learning about the components of the drone, assembling, soldering, safety and handling procedures. And then we move to the software with teaching Linux, networking, ROS, control, estimation, localization, and finally SLAM. And the student has to learn how to code this behavior, how to tune the parameters. They can simulate and test on the hardware, and they can finally develop their own capabilities if they want. So I'm going to show you the evolution of the drone, which started out as a project at Brown University and has evolved from the DD18 all the way to the current DD24, based on the criteria of having an accessible DIY build, having safe indoor usability, and good onboard computing. So the first iteration of the drone was the DD18, which started as a collaboration between Professor Stephanie Telek's lab at Brown University, who took care of the pedagogical materials, and Duckietown, who productized the drone, with the support of Amazon Robotics for funding. It was a low-cost platform based on the Raspberry Pi 3B, with all onboard autonomy using Python and ROS. Used PID control for velocity, altitude, and position control, UKF state estimation, and localization and SLAM using particle filters. We can see here videos of the students working with the drone. Then we evolved to the DD21, which improved the frame, the design of the drone, the onboard compute capabilities. It introduced an infrastructure, a software infrastructure for a reproducible experience using a Docker container, and greatly improved the documentation. It was offered as an all-inclusive DIY kit again, this time so with the Raspberry Pi 3B, and these are size and dimension. And finally, what I'm going to present to you today is a new drone, so the DD24, which has been released this year. And it has great improvements in terms of safety, thanks to a new design which incorporates propeller guards and a smaller footprint, greatly improved onboard computing, and a much more robust autopilot, an enhanced sensor suite, and a fully containerized software architecture. This is, again, a fully all-inclusive DIY kit. The only thing that you're going to need is a soldering equipment. And it's available for $429 without the Raspberry Pi, but also as a complete kit for $50 more. So we made a lot of improvements to the hardware of the new drone. We have greatly reduced the number of components that we use and the amount of soldering required to build the drone. And also, this enabled us to greatly reduce the time it takes to build the drone itself. We have a new wide field of view camera and more laser time-of-flight sensors. And these specifically enable environment perception with the camera mounted at a 45 degrees angle rather than just pointing downwards. And also, the new time-of-flight sensors allow to estimate distance at 360 degrees around the drone. So this enables, for example, scenarios such as flying into very tight spaces. And thanks to the bigger battery, we also increased the flight time, and currently it's about 18 minutes. So how did we improve the computing? We moved to a new flight controller, which is the SpeedDB F405, and this enabled us to use the ArduPilot software, which is much more robust than what we were using previously. We provide to the user a pre-configured settings file so that they can just flash it on the flight controller, and they have everything set up as needed for the drone to work. And we also moved to a Raspberry Pi 4B, and if you want a Raspberry Pi 5, which is in beta support. So we have a quad-core ARM platform, and it strikes a good power and weight balance with the performance that we want. We have a Flash and Fly OS image that you can just flash on the SD card, and it's based on Raspbian and allows you to set up the drone and fly. Our strong point is very thorough documentation. We have an operation manual that provides an overview of the components. It gives safety instructions, assembly instructions, walks the student through the software setup and first flight. And we also provide an instruction manual. We have a new assembly tool that walks the user step by step through assembling the drone. And the user, it's a 3D tool, so you can just hover around the drone, move it around, play as you want. If you don't understand the step, you can look at it again, zoom in. So it's very, very easy to build reliably the drone without making mistakes. So we started with a legacy autonomy stack. We provide this stack as to have an identical UX to the old drone, the DD24. We call this the V0 stack, and this runs in a monolithic Docker container and has low-level control by sending RC commands to the flight controller. In this case, it's still running beta flight, and then it builds on top of that by having velocity control and position control using the camera by computing optical flow. And finally, you have high-level functionality with localization and monocular SLAM using particle filters. What I'm really excited to show you, though, is these are some of the applications that were available. So the unscented camel filter and localization and SLAM. And these are some examples of like use cases that were available that have been developed by, in this case, I think it was, Stephanie Telek's laboratory. So we have the drone flying around the map, for example, using this augmented reality setup. So as I was saying, what I'm really excited to show you is the new autonomy stack that we have developed. We call this the V2. And this is a fully containerized stack. We run each of these nodes into a Docker container. And again, we have low-level control. This time we send commands over Mavlink to the autopilot based on ArduPilot, which is much more robust with respect to what we were using before. And we also have the same autonomous flight modes, still, again, running these nodes in Docker containers. And they again provide velocity control and position control. And we're in the process of porting over the high-level functionalities, such as localization and monocular SLAM. We offer a browser-based UI, which is called the dashboard. And it's an onboard interface with all the robots functionalities that you can just access through the web browser, and it integrates with the Duckietown UI and UX. For example, this is the mission control page that allows you to fly the drone around and view the sensor streams and everything. The development workflow that we support is the TT projects. So they are templated software entities where we provide template repositories for everyone to develop on. They can just fork the repository and develop their own code and deploy it through the Duckietown shell. And this allows us to have good usability, maintainability of the code, and modularity. So you can just replace any node you want with one of these or build on top of that. And you can either run the code directly on the robot, or you can run it on the laptop and connect through the ROS topics. We offer a developer manual available on this link for anyone if you want to dig into that. One new very cool feature that we enabled is the software-in-the-loop simulation in the Duckiematrix, which is a 3D simulator developed in-house. And this has been enabled by the containerized architecture that we have. So basically, we show you here an example of, we have the simulator down here in the bottom center, which uses a Unity engine. And it simulates using software-in-the-loop sensing and acting of the Duckiedrone in a Duckietown. And basically, you run all the exact same containers that you do on the real robot, but on your laptop, and connect the sensors to these simulator sensors. So you can see, for example, here an image as seen from the camera of the visual robot. And here we're computing the optical flow, and here we have the speed of the drone, the estimated speed. And it's a scalable architecture. There's a backend and a front end that enables parallelization. And you can also develop your own maps, and you can even add scriptable entities to the map. And we're in the process also of developing an API for the gym environments for enabling reinforcement learning workflows. We offer in the V0 stack the learning experiences, which are Jupyter notebooks running in a Dockerized VS Code instance. And they offer modular learning activities that can be deployed in simulation or on hardware. And there's several LXs about sensors, PID, filtering, SLAM. And we are in the process of porting this to the V2 version as well. And we offer a developer manual available on the website. We have a link here about the supported LXs. Oh, and very important, these are also available as templates. So if you're an instructor, you can develop your own LXs to teach whatever you want about drones autonomy, or also, in the case of the Duckiebot, ground vehicle autonomy. So to sum up, we achieved a lot of milestones with this new version of the drone in performance and capabilities. So we have much more compute power, thanks to the Raspberry Pi 4 or the 5, if you choose to get a 5. And we have a much more powerful and expandable flight controller with a more robust firmware, so RGPilot. And we have greatly increased safety thanks to the new design. It's very hard, almost impossible to hit anything with the propellers. And this is great for the indoor use case that we support. And the autonomy stack has been fully containerized. So it's very modular. It's very easy to swap out and in your modules. And there's a simplified initial setup and integrate a much stronger and tighter integration with Duckietown, the Duckietown ecosystem. Steps forward that we envision are the support of ROS2. So we are in the process of porting the hardware drivers of the ROS2. We have most of them working already, and we plan on also moving over the whole autonomy stack to ROS2. And also, we plan to release this mini MOOC series, which is going to be a drone autonomy with Duckietown MOOC, which builds on top of the self-driving cars with Duckietown MOOC experience that we already offer, and walks the students everything from making a drone, building the hardware, to learning-based autonomy. It's going to be led by Brown University for the lectures. And Duckietown is going to provide the infrastructure for the drone, the hosting of the learning experiences, and it's going to provide support to the learners. It's going to be free to the learners with optional hardware if you want, or if you don't, you can just try it in simulation. And we're going to have guest lectures with industry and academic leaders. Yeah, so that's all on my side, and you can reach out if you have any inquiries, if you're interested in what we do. Feel free, there's several links here to reach out. And yeah, I am open to any questions that you have.
All right, thank you, Davide. Very interesting. There seems to be already a couple of questions up, so I'm just going to do the ones who are raising their hands. So you were first, so go ahead.
Yeah, thank you. Well, first of all, let me tell you that this is also my first, the first time I am attending this meeting, so hopefully I can keep on attending. It was a really nice presentation. I had a couple of questions. One is more like a curiosity. Have you considered for the simulation analysis that you were showing? Have you considered using some tool like Foxglove, for example? And if so, how hard do you think that it would be to integrate or to use? That's one question. And the second one is, since now you have that, do you consider building a kind of higher level rule set to analyze the simulation? For example, there was a steep gradient in the altitude, rather, you know what I mean, like higher level rules that could flag some issues?
Yeah, so to answer your first question, yeah, absolutely, it's definitely supported. I'm actually using that tool myself sometimes to like debug some things, and we're also in touch with like the Foxglove about possible avenues to collaborate. But yeah, it's definitely something that we support. And I mean, at the end of the day, it's ROS. So if you can connect ROS to it, you can definitely do anything you want with it, basically.
Yeah, by the way, just a disclaimer, I'm not associated with Foxglove. Okay, so I'm not trying to sell anything.
No, I get your point. It's a useful tool to have in your belt. Yeah, regarding your second question, I think I'm not sure exactly what you mean. Like, what will be the goal of like this kind of like analysis? You mean some like evaluation of behaviors, for example? So
yeah, for example.
Yeah, so you like deploy an agent and you have like some predefined metrics to
correct.
Okay.
Yeah, like for example, it would be useful for integration tests, right? I mean, if you have different components and you have tests for each component, then you can just put them all together, and see if there's something that flags up on your target behavior.
Yeah, it's definitely on our timeline. It's actually one way that we kind of like thought about testing the whole autonomy stack when we do like changes to the code. You can just have this thing running in a CI environment, basically.
Exactly.
Yeah. Yeah. Okay, I get exactly what you mean. Yeah.
And is this like some? So you sorry, I'm not. I don't want to be like hogging the question sections. But do you have like open source projects going on that people can contribute to, like in these links? In your stack, is this like open source and people can just contribute to if they want? Yes. Okay.
Yeah. So most of basically all the stacks running on the robot is open source. There's like GitHub repositories. Actually, if you go back, there's like these are actually the names of the repositories. The DT core and DT document interfaces, the names of the repositories themselves that we have on our GitHub.
Nice.
And I'm not sure whether the Ducky metrics is open source yet. I think we're still like working on it. But yeah, the aim is to basically at the end, once we develop the GIM API, we would definitely want to support something like a continuous integration workflow that you suggest.
Cool, really cool stuff.
For the question.
All right, thank you, Hugo. Mayank, you're up next.
Hey guys, DD24 looks really cool. Hey David, how are you? Hey, so I was just curious. Sorry?
Just nice to see you again.
Yeah, nice to see you too. DD24 looks really cool, man. A lot of good work has gone in. I was curious how much of the older PyDrone package with like ROS Kinetic did you guys keep around, or did you do like a whole rewrite with what you've presented with DT Core and like the new interface layer? And is it also based on ROS1 Noetic, or how is it now?
No, we definitely used that code as a base to develop our new stack, and we did some pretty heavy refactoring. We added a lot of capabilities for like logging, diagnostics to ROS. So there's definitely some of that code still there, but we added a lot on top of that.
Nice. And the learning experiences that you showed, are all of them supported in the Ducky matrix, like with the new simulation, or is it just that you have a couple of demos, but maybe a lot of the LXs right now are still on physical hardware?
So currently they're still on the physical hardware, but for example, we have we have Duckimetric Cell-Access for the Duckybot. So we do support that workflow. That's actually the one workflow we're gonna try to like support going forward. And so definitely we're gonna basically move the drone to the same workflow.
Yeah, and I think I'd ask you this on Slack as well, but maybe because Jacopo is here, I would really love like an upgrade kit kind of option if just for the frame, because when I was trying to work with the DD21, the props would just keep bumping because I don't have enough space like educational institutions. And I got the basic hover and everything working. I was able to tune the PIDs, but maybe I wasn't able to go as far as I would. And I think you guys have done amazing work with increasing the battery life as well. I usually get like maybe 6-7 minutes out of my DD21. So I was looking if there's a plan to maybe have a way for people to like have an upgrade kit if possible. That's like more of a request at this point, but that would be awesome. If like I know some of the bomb components are different, but yeah, like a Delta upgrade would also be like really fun to try out.
Yeah, I'm not sure if we currently support like having an upgrade kit for the DD21, to be honest.
Yeah, which is why I said like that's why it's more of a request if possible. But yeah, but great work. And yeah, I'll check out the autonomy repositories as well. And if I can contribute like to the simulator stuff, then I'll get in touch for sure. But great work.
All right, awesome. Do you have any experience with ArduPilot, soft in the loop?
Some, yes. I've done some testing for like we were working on pre-arm checks for some certificate verification and things like that on another project. So I have some experience, but yeah.
Awesome. I'll get in touch with you about that. Thank you.
All right, thanks, Myung, for your question. Yeah, I think the next one is Joshia. You can go for it if.
Hello. Good evening. I think it's evening on my side. So I'm Josiah. I'm from Nigeria. So I'm in a school and I want to work on drone for cleaning high-rise structures. So because we don't want to burn money, waste money on like building part and burning part. So I just want to ask, like based on this community, what do you use for modeling and simulation that will be really, really effective for high-rise cleaning drones and will take in all the scenarios or all the things that could go wrong and allow us to just go straight to our building and we will not have to spend or waste a lot of money spoiling things. So that's my question. Thank you.
Yeah, I guess throwing that back to anyone who wants to answer about simulation tools in general. I mean, obviously we have one simulation tool, but I think this is a much more general question. I guess something like Gazebo would work.
I've just shared the simulation page of the aerial robotic landscape.
Yeah,
like I was a co-author of a paper for the survey of simulators for aerial robotics. So that paper would probably be quite handy to go through. I'll also share the IEEE Explorer, but there is an archive, an open archive version of it as well. There's a lot of simulators out there, but perhaps like the nice overview of that, of like which capabilities per aerial robotic simulator is there, maybe can help you with your choice. And if you have any more questions, make sure to. We have a Discord on Open Robotics, like the CWG aerial. You can ask some questions there or contact any of the co-authors of that paper. We're happy to help out. I don't know if anybody wants to.
I remember that was very thorough. There should be a recording for that, right?
Yeah, we had a meeting indeed in September.
Yeah.
Yeah, exactly. Yeah, very, very good. Yeah, I don't have the link to it right now, but on ROS Discourse, if you look at the September meetings, we linked to a recording to one of my co-authors of the paper, Giuseppe, who gave a presentation about that. Cool. All right. I think there was one more hands up. I think Ryan, or was it you?
Yeah. So I was curious, you're porting your autonomy stack from ROS 1 to ROS 2. Are you doing anything when you're doing that other than, you know, switching out the middleware? Are you taking it as an opportunity to refactor things, or are you trying to basically do it as quick as possible? What's your sort of plan for that migration?
Yeah, so we've done like kind of a big refactoring, moving to this Dockerized infrastructure already. I think, yeah, we haven't really planned that, like how to like build the autonomy stack for ROS 2. Like I think right now the plan is to basically just move as fast as possible, get it to work, and possibly refactor afterwards.
Cool. Do you have any like challenges that you're worried about moving, or do you think it's going to go pretty smoothly?
I mean, from what I've seen, the API is very similar, so it shouldn't be too hard. The only thing is that we use this like DT ROS class that has some customizations on top of the plain like ROS Python API. So we're gonna have to see whether we want to adapt that or just go with plain ROS 2, you know.
Great, thanks. Really awesome job.
Thanks.
All right, thanks, Ryan. Mayank, you had one more last question.
Yeah, I was just wondering, like, if you've considered an approach where you do like a phased migration, because two would allow you to have like a 2-to-1 bridge and keep some of your nodes and entities in ROS1 while you move maybe the higher priority stuff into two. So that could also be something that's worked well in the past for a lot of people.
Yeah, I've tried in the past to use this like ROS 2 to ROS 1 bridge. Like I guess you're envisioning using that for what you're saying, but I found it's a bit like it doesn't work that well. So I think we would rather just move directly to ROS 2 rather than phase it. Obviously, like it has to be done step by step. So right now we're getting the drivers are, I think almost all of them are working, and then the autonomous behaviors on top.
All right. I think we'll just close it for now. But at least like we managed to see the new Duckiedrone in person, like at ROSCON, and me and my BitCraze colleagues.
Yeah,
that's flying in our cage.
So, oh yeah, I should have added the video here.
Yeah, like yes, yeah, I don't have the video.
No,
my
but
colleagues
Barbara sent it to me.
Yeah, exactly. Yeah. So it's but thanks a lot for presenting this to us. I think this is going to be
thank you for having me here.
Super useful for anybody who wants to learn and get into aerial robotics. Make sure to, if you want, also add the Duckiedrone simulator and the MOCC, like the mock on the aerial robotic landscape once it's ready, and then more people can see it, of course.
Our last task before releasing the simulator.
Awesome. I'm just going to share my slides. If you could unshare your slides. So I'll be. So this is already going to be the next meeting. Although I'm just going to do a slightly secret announcement, putting my ROS ahead of. If there's anybody that's near Brussels in February, like beginning of February, perhaps, there is a very, very big free conference for open source software developers. And since first time ever, there's a robotics and simulation developer room. And the call for participation is still open for that. So, like, you know, it's not aerial robotics, it's all robotics and simulation. So, the Duckiebot for us, for instance. So, yeah, like, we're still looking for proposals for talks there. So, that's my ROS hat back on. And our next meeting for the aerial robotics meeting is going to be a bit of a Christmassy theme. Davide, yes, you had one more question?
No, just do you have a link for the conference?
Oh yeah, of course, yes, yeah. Like that's why it was kind of like a last minute. Let me just share you the link. I was planning to share this on the let's say the recording post of the ROS Discord.
Yeah, that works.
Yeah, but I'm also going to add it here. Very bad of doing things at the same time. Here you go. So the call for participation, you can go there. It's a very yeah, you don't have to write a full journal paper in order to get the presentation. It's just like an abstract. Like, a part of the things that you're presenting needs to be open source because it's an open source conference. But as long as that's the case, then you're more than welcome. It needs to be robotics as well. Yeah. All right. Cool. Yeah. Okay. So the next meeting for the Aero Robotics community group is going to be a bit Christmassy because it's going to be on the 18th of December. Probably a lot of you are going to be already maybe on your holidays, or Christmas holidays, or on your break. But I do hope that you'll be able to join because we're going to have the new Christmas video of BitCraze with the crazy flies and a special announcement from BitCraze as well. Maybe a new brushless, perhaps. But yeah, it's still to be confirmed. It also kind of depends on what my colleagues at BitCraze are able to do so. But there's going to be some Christmas videos and flying for sure. I'll make sure of that. The GitHub organization is at github.com/Ariel. And also again, Ariel Robotic Landscape, add an info page if you like, or information or a course. That is, we're more than welcome to have all of those extra links and information there. So thanks a lot again for joining. Thanks again to Davide for the presentation about the Duckiedrone. And I hope to see you next time. Right, thanks for joining.
Thank you.
Thank you.
Bye, everyone.